This is called a reliability block diagram, and each shape within it is called a block. The idea here is that if we can draw a line from one side of the diagram to the other, passing through blocks that represent components that have not failed, our system is still working. A line like this is called a success path or a tie set. The reliability block diagram for our bridging system has 4 success paths or tie sets that are able to pass through combinations of blocks representing pumps and the switching valve. These show us how particular component failures affect or do not affect our system's ability to work. So we can use all the success paths or tie sets to work out which combinations of component failures will cause system failure. Now, reliability block diagrams can be just as useful as fault trees when it comes to modelling system reliability. And in some cases, like for our bridging system, they can be even easier to use than fault trees. That's because reliability block diagrams often follow the physical layout of the system, which makes it easier for some people to understand the system. That's especially true for parallel pump systems, where the block diagram looks very similar to the physical pipeline layout with parallel success paths. For series systems, the reliability block diagram also looks like the physical layout of a pipeline, where we have a single success path with component blocks drawn one after another, or in series.